Announcements. Today's Wednesday. This Saturday comes this pen testing course, so come to campus on Saturday if you want to attend it in person. You can also connect over Zoom. If you want to attend it remotely, it's worth extra credit in either case. And the embedded device capture the flag contest, sign up by the end of the semester if you want to participate. That'd be a good thing to do. And some people are going to take like 197 to get credit for doing it next semester. Another option would be to get extra credit in any of my courses next semester. It's not really going to happen, I think, until after Christmas, but you can sign up now and get on the team. All right. Anyway, so let's take a look at these other techniques to attack users. All right. So client-side injection, we've already talked about quite a few of these. JavaScript injection by cross-site scripting and cross-site request forgery. You can also put data in a header. So remember, when you do a GET request, it sends things here like set cookie. So in the location and set cookie headers, if there's a set cookie here that says preferred language equals English, then this data came from the user. I got some kind of page, and I got a user-controlled parameter telling it what language I want, and it's going to return that in a cookie. Then now there's something under my control in the header of the HTTP response. And that's another place you can put scripts and other nasty things. So one thing you could do is inject another header. I could put another header here. I could insert not just English, but English, carriage return line feed, foo, bar. And now it'll be a set cookie and another header, foo and bar, which could be anything. If I join Saturday Online, will I get credit? Yes, you will, Ronnie. Online is fine. Good. Anyway, so, all right, so one way to check this is to see if either of these can get through. If you can inject a carriage return or a line feed, then you can put in an extra line of data in a parameter, and there's various, you can try the usual tricks, put in a null byte, double encode it with, I think, strange double patterns here, so if you're trying to remove %0a, there'd be another %0a left, you know, the usual thing. All right, this event on Saturday goes all day from 9 to 4. All right. All right, and so you could inject a cookie like you have here. So here I have English, then I have carriage return line feed, then set cookie section ID equals something, and now you'll have a session ID set in the header from here. So I could then put a cookie on somebody's machine that appears to have come from the server, although it didn't, and it would then persist. You could control the entire body of a response. This means you could actually put a whole web page in that did not come from the server, or scripts, or redirect it. So this is called HTTP response splitting. Let me zoom in on this. All right, what you do is you put in all this highlighted stuff. So I put in author, and then a carriage return, and then the content linked in 2 carriage returns, and then I put another whole web page here, so your browser will show you this entire malicious web page. And the original content down here will start at a character that is now ignored. So I can take the whole web page and replace it with a completely false web page that I inject. This is called HTTP response splitting. All right. So let's give it a try at this header injection demo. I've got it set up in Burp browser, if I can figure out where, there's the Burp browser. All right. So okay, so here we are. Just the thing, you have a language is English. So when I submit it, it goes to a page here with the language of English, and, well, that's rude. Looks like my server is not responding for this one. How rude. All right, I'll have to deal with that later. We'll just look at the pictures tonight. My demo is broken. All right. And so it's just the same thing you saw. You can inject whole things here, a whole web page. So another thing you can do is poison the cache on a proxy server. And we talked about this on the DNS class for poisoning DNS caches, but you can use response splitting to poison other caches. So here I send a request, and again, I have a parameter where I get to put in a carriage return line feed, add content length, add a whole page. Now I request the page, and it sends me the response. The split response has 2 web pages, and they're both going to get cached on the proxy server. So now when other people try to get the page, they're going to see the fake page I injected. So that's a pretty cute trick. All right. So if you want to present this, don't use user-controlled input into headers, just like everything. We talked about this many times. This is how most of these attacks work. There's something user-controlled that is used without being sanitized. If you have to take data from the user, then use input validation or output validation. Filter all the bad characters out of it on the way in, or filter all the bad characters out of it on the way out, or both. It's the safest thing to do. All right, and then you can set or modify a cookie. I may be able to do this if I'm able to get a parameter and add a cookie into it, or header injection. All right. So I can also set a malicious cookie by cross-site scripting. We talked about this before. We talked about using cross-site scripting to steal a cookie, but you can also use it to set a cookie, sending a response. All right. And if you do that, if you set a malicious cookie by a man-in-the-middle attack, for example, the attacker can set cookies for arbitrary domains, even if it uses only HTTP, and its cookies are flagged as secure. You can still set an attack with a response. Since you can make a response that will enter the browser will think it came from a server and set a cookie. Now, why would you set a cookie on someone else's machine? Stealing a cookie, it's obvious how that benefits you because it's the Remember Me cookie you can get in their account. But what good would it be to set a cookie? Some apps can change their logic in response to a cookie value, like use HTTPS equals false. Client-side code may trust the value and use it in dangerous ways, like displaying it on a page so it can lead to cross-site script or JavaScript injection. Some anti-CSRF tokens have their token in both a cookie and a request parameter, so I can bypass that defense. That's another possible consequence of being able to set a cookie. And if I have a same-user persistent cross-site script vulnerability, then I can use cross-site script forgery to trick the user into loading the script, but I could also just put my session token in the user's cookie, and they would then load something from my session. It's another way to do it. There's also session fixation vulnerability, which we talked about before. There are some websites where, now a normal website, when you log in, it sets a session cookie. But there are some websites where if you already have a session cookie value, it will use it. So I could feed you a session cookie value for a website, and then when you log in, that will be your cookie. And I already know that number, so it amounts to the same thing as effectively stealing your session token. And that's what this is. That's what it's saying. So if the app creates an anonymous session before login, and when you log in, it upgrades it, then I can just send you get anonymous session and send that to your browser, and now it will count that as your identifier, and the token will gain privileges. All right. So you can check the token cookie injection. If the token is in the URL, then you send session ID equals a number up here, and I can just set it that way. Some apps let me add that token, and if it's in a hidden HTML field, you can cross-site script forgery. There's various ways to do it. And without login, remember, even when you have not logged in, say to Amazon, there's still cookies to identify you to target ads. So an anonymous user could browse products, put data in a shopping cart, check out. Here's the normal process. Check out by submitting personal data and review data on a confirm order page. I do all this before logging in. Then I fix an anonymous token in the target's browser and view the confirm order page to steal data. So I could capture the data in your order page by fixing that token on someone else's machine. And now when I refresh my page with that token, I'll see what they put in their shopping cart and what their personal details were. All right, sometimes I can send in arbitrary tokens, even ones that didn't come from the server. Now, usually they expect it to have the format of the server token, some long number of a certain number of hexadecimal bits, and maybe even something that can be decoded to something meaningful. But sometimes I can just send an arbitrary token that's not even in the right format, and it will accept it. IIS and ColdFusion did this in the past. So I can just send you a link with an arbitrary token embedded, and if you go visit the page from that link, you're using a session token that I provided. All right, so to find this, just review handling of session tokens, see if it assigns a token to the anonymous user and upgrades its privileges on login. That's a poor practice. What it should do is issue you a new token when you log in, and then try, if you log out and log in again, see if you keep getting the same token. That's another case in which this would happen. All right, in either case, I can get a token and feed it to you and hijack your session that way. And even without a login, I might still see things, as I talked about before, that are in what you do on the site before logging in, because it's still tied to your token. So to prevent it, like say issue a fresh token every time someone's authentication level changes, and employ per-page tokens to make sure that the user always comes from the previous page you think they came from, and don't accept arbitrary session tokens. Only accept session tokens that are issued by your server and therefore in the format your server expects. All right, then there's open redirection. This used to be very common on the web, and I think they still see it pretty often, where a page moves to another page. When you're done, go to see this other page for some reason. And so it takes user controller input and lets you change where it goes. You can use this for Rickrolling. You can make a page that looks like a Google page, but when you click it, it redirects to some other site like a joke, and therefore phishing attacks. There was a recent one that just came up in the news. In fact, let me bring that up. That was a news article a couple days ago that's quite relevant to this class. Let's see. Yep, this is it. What this one did was they wanted to send a Word document as an attachment to an email, but it's going to have malware in it, so they're going to get busted by antivirus solutions. So what they do is make a corrupted Word document. Word documents since 2008 have been zip files. They are XML, plain text files, zipped. Zip archives is what Word documents have been, all Office documents have been. So they then corrupt the header by changing a few bytes, I suppose. I don't know exactly how, but they make it so it will not unzip. So now your antivirus solution can't unzip it to see the malware inside, but Word can. When you try to open a corrupt document in Word, Word will offer to fix it. Here's Word. Word will send you a message like this. Word found unreadable content in this file. Do you want to recover the contents of this document? I've seen this frequently. Word makes mistakes saving files, and it tries to fix them. So you can actually open it in Word, but your antivirus can't open it, so it's a way to sneak bad stuff past it. All right. So anyway, that's another fun attack. All right, one of the many phishing attacks people try. And having a URL that redirects you to a login page is another way to do it, where you have a link that's supposed to take you to something like a Google login, and instead it takes you to a fake page that looks like a Google login, so you're actually sending your data right to the criminal. And there's a lot of ways to do it. You can have similar domain names like a misspelled domain name, and hopefully people won't notice, and so on. So to find open redirect, find these 302s, that's object moved, where some page is moved from one location to another, and they expect people to be coming in on the old link, so they'll get this 302 redirect going somewhere. And there'll be an HTTP refresh, is another technique, a header people use to redirect things. And if you can control the destination it's going to, by header injection or any other means, then you can change where that redirect goes. All right, here's the HTTP meta tag. I used to use this all the time. You refresh within 0 seconds, go to this other location. All right, and here is the JavaScript API is another way to do it. Document location equals something. If you can execute in a script, you can just set document location to something. That's how you redirect. They're typically not user controllable. But one place where they might be user controllable is if it has a return to original page, like after a timeout and login. See if there's a URL that contains a domain name somewhere, a parameter that you can control. All right, and Hackathon had one. Open redirect was misidentified as remote file injection, but if you look here, it's got return URL equals google.com, and that's what it has. This is a return page after you log in, where it's going to go after you log in, and you can change it here to a different URL, and that's an open redirect. There's a parameter you control, so you could send this manipulated URL to somebody, and when they click it, they think they're going to Hackathon, but they're really going to end up bouncing to some other site. All right, you can try to prevent these by blocking absolute URLs or having a specific absolute URL prefix, so the only thing you can control is the folder or file name that must be on a certain server. That's one way to do it. So if you want to block HTTP, you might be able to sneak it in this way with the usual tricks by distorting it. And if you to sanitize an absolute URL, you remove HTTP in any external domain. If it's doing that, you might be able to do this sort of thing, where the attempt to remove HTTP or remove the domain is not really going to get rid of it, the usual stuff. All right, app may verify that the user string starts with the expected domain name. So in that case, you might be able to make it look like it's going to the right place and then put the bad stuff after it, put some kind of special character in here to separate the two. So it looks like it's going to this domain, but it's actually going to that one, that sort of thing. All right. All right, so apps only take the data from the user and prepend it with a absolute prefix. So all I get to put in is like updates, update29.html, and it's going to add to that mdsec.net. So that's a way to prevent this. And however, if they forget to put the slash at the end, then it's still vulnerable. What I can do is I can set it to .mdattacker.net, and now it will be mdsec.net.mdattacker.net, a subdomain of the attacker-controlled domain. So this is a possible flaw. If you forgot to put slash at the end, you may still be vulnerable. All right, so to prevent this, of course, don't take user-supplied data and put it in a URL where you're going to. That would be best. It's better if you must allow that than just have a list of targets and you have to choose from known good targets. Would be a lot safer. If you must use user-controlled data, then the redirect page should verify that it begins with a single slash followed by a letter or something like that. You know, have prepend every URL with this, including the slash, verify that every URL starts with the good stuff, that sort of thing. Suspiciously treat it. All right, and then of course, client-side SQL injection. Now we've done a lot of server-side SQL injection in this class, where you send data to a server and steal data from the server, but there is client-side SQL in principle available, so apps can store data on the client side, and then you can have data and run your app in offline mode, and then you could use client-side SQL injection to attack it. I've never seen a website like this. I don't know how common it is. HTML5 added these features. And so then you might be able to steal whatever feature is stored locally, like users' contact information, comments from news apps, and so on. And then you can have HTTP parameter pollution. Remember, parameter pollution is where you set the same parameter twice, and therefore you can confuse a server and get away with doing something like elevating yourself to admin or something. You can also do it on the client side. So a webmail loads the inbox with this, folder equals inbox, order equals down, size equals 20, and so on. So here's a link that allows the user to reply to a message. It's going to do action, folder is inbox, start equals message, action equals reply, and so on. So it's got a link that uses several parameters from the inbox's URL. So if I can trick them into opening an inbox with extra parameters in it, like start equals this, then the reply link will be start equals 1, action equals delete. Now instead of writing an email, it will delete messages. That's the sort of cross-site request forgery consequences. All right. And then there's local privacy attacks. If you can use the same computer someone else has used, this used to be a pretty big issue in the lab when students would walk up to a machine a previous student had been using. And it's happened to me many times when people come up to my classroom machine, then they can get in. Same thing if you steal a cell phone or a laptop while it's still logged in. That's the problem with persistent cookies, especially on mobile devices. The cookies are usually good for a very long time, usually forever. Browsers cache content unless you tell them not to, so there will be stored data on the machine, and in a forensics class, we're digging this stuff out of the web cache. All right, you got browsing history. There may be stuff in the URL parameters. Autocomplete will often have passwords and such, and you can steal it by cross-site scripting sometimes. Flash had Flash cookies, but I don't think anybody's using Flash anymore, so this doesn't matter. Internet Explorer had a custom storage system, but I don't think anybody's using Internet Explorer anymore, although apparently Edge does also store local private data. And HTML5 has more local sessions, ways to store data in the browser, so if your page is using these advanced features, then there might be exposed if someone gets access to your machine. I'm not sure how much of that is actually being used. HTML5 added a whole lot of new features to the web, and I'm not sure how many people actually use them all. So your app shouldn't store anything sensitive in a persistent cookie, even if it's encrypted, because a user could replay it even if they can't decrypt it. And there are cache directives to prevent sensitive data to be stored by the browser. There's ASP instructions to prevent caching. telling it response expires and no cache. And there's Java commands to do the same thing, to set no cache. So don't use URLs to transmit sensitive data. It should be sent in post data. We talked about this before. That's where it should be, because the post data is not stored in other places like the favorites and such. All right, then you can attack the browser itself. This is the way a lot of people used to get into jailbreaking iPhones. They would find a vulnerability in mobile Safari. Haven't heard of one of them in years, but that's, of course, one way to get in. So now you can have JavaScript that will monitor keys pressed while you're typing in the browser window. That you can do. That's not too hard to do. And I had a demo years ago that worked in Windows 2008, but it didn't work in later versions. And it can only capture keystrokes while you're typing with the frame in focus, the frame that's running a script. So it's not at all as powerful as having normal keylogger malware on your machine that steals all the key presses. All right, but you might be able to embed a third-party widget or advertising frame in a page and get this script to apply to another page. A little bit tricky, sort of like the UI redress we talked about last time. You can steal the browser history, of course, and search queries. These things are saved in the browser and easy to collect. In the forensic class, we use Autopsy, and it can totally show your queries and your browser search history and your browser browsing history. That's easy to steal and very often used in court. I've heard of cases where a woman was going to court for murder. They said, "You poisoned your husband, and as part of the evidence, here you are a week before Googling, find a good poison to kill my husband." So anyway. All right. And of course, you can find out what applications they've been using. You can determine what applications they're currently logged into. By requesting a page, it can only be seen by logged in users, and then it won't load the page correctly if they aren't logged in. So you can use script to make queries to find out if they're logged into certain sites. And all right. You can do a little bit of port scanning from inside a browser, but the browser can't see the response, so it's pretty tricky and pretty limited. It's not at all as powerful as being able to run Nmap, but you can do some local scanning of the network. All right, but a lot of it's limited by modern browsers. And after you find a horse scan, you can then try to look for known files, try to load things, like you can find the gateway and then try to see if it's a Netgear by seeing if there's an image on there called hmicon.gif, that sort of thing. Then you can exploit known vulnerabilities like a default password and so on. It's possible to set these up. There used to be a thing called the Browser Exploitation Framework that would do all this, and it turned out to be pretty lame in practice because they keep patching these attacks in the browser, and they only work with certain devices under certain conditions. So I tried to make homework projects out of it, but I discarded them pretty quickly because they really aren't very effective. All right, you can send arbitrary binary content to a port, but it will always start with an HTTP header. So some services you can exploit, but you'll have to have a service that will actually ignore extra content at the start, and that's not too many of them. You can do cross-site scripting from non-HTTP services in principle, but only under these special conditions. Running on a port that's not blocked, it tolerates unexpected headers, it echoes part of their expressed content. So, it would be an exceptional case where you find this actually working from inside a browser. I remember when Beef came out, they said, all I have to do is get you to visit a web page, and now your browser is like I had a rat on your system, controlling it. I can use your system to do things. And it turns out after a while they put in defenses, so in fact you can't really do that much. Anyway, and of course there can be browser bugs or browser extension bugs. Now that happens a lot. In fact, the common thing now is a supply chain attack where you have an extension, like there's one on Chrome that gets rid of YouTube Shorts, and somebody just bought that and put malware in it. So when you put the extension in your browser, you're adding malware. Now they can do anything your browser can do. That's the simplest way to get that malware into your browser. It's just trick you into loading an extension that is malicious. And then DNS rebinding is another pretty extravagant attack. The techniques to do it were so inefficient and slow. I made a project, but I didn't leave it in the class because it was too hard. But the idea is you have a DNS server to resolve a domain name, and you sometimes resolve it to a public IP address, and you sometimes resolve it to a loopback IP address. That's the trick. So this causes the browser to make requests to a web page, And then some of those requests are sent to your local network instead of to the remote network. And the reason this works is because of the Internet of Things. Now that people have all kinds of smart devices in their house, like a smart thermostat and a smart TV and everything, a lot of those devices don't actually make you log in to do things. What they do is detect if the request came from your local network. And if it did, they say, well, that is the user at home. That's all the authorization you need, and therefore this DNS rebinding attack, I can take a website, the script I put on there, and I can trick your local network into believing it came from your browser. It sounds pretty cool. In practice, it's pretty difficult to do. Anyway, all right. And I mentioned Beef and XSS Shell are browser exploitation frameworks that let you run all these attacks. And like I say, in practice, I don't think they're really very effective anymore. I think the browsers have defenses that pretty much stop most of the fun things here. If you use unencrypted communications, then anybody can get in the middle and inject scripts. That's why it's really unsafe to use HTTP for anything. You can't even safely use it to load non-sensitive content like images, because an attacker in the middle could just add script to that response. There was a time when a lot of sites used both HTTP and HTTPS. Google uses HTTPS for everything. When I checked a few years ago, Amazon was still using quite a bit of HTTP. I don't know if they've upgraded it yet or not. Like I say, it's dangerous because I could add that. And HTTPS only domains like Google, I could still induce you to make a request over HTTP to some server, and I might be able to take the response and add script to your browser, but it would be a little difficult. All right. And all right. Anyway, that's all for this one, and I don't think I have any Kahoots for this. So I think that's it. Let me stop the recording of the lecture.